Hello everyone, welcome to another video. আজি আমি পঢ়িম ইনজেকশন ফাংশনৰ বিষয়ে। ইনজেকশন ফাংশনস ইয়াক আমি 1-to-1 ফাংশন বুলি গম পাওঁ। তো এটা এক্সাম্পলৰ দ্বাৰা চাওঁ। Every student in a classroom receives a unique roll number. No two students share the same roll number. তো মানে কি এটা ক্লাছৰুমত থকা প্ৰত্যেকজন ষ্টুডেণ্টৰে এটা ইউনিক ৰোল নম্বৰ থাকিব, নিৰ্দিষ্ট এটা ৰোল নম্বৰ থাকিব, আৰু দুজন ষ্টুডেণ্টৰ কেতিয়াও মানে ছেম ৰোল নম্বৰ নহয়, ৰাইট? তো এইটো এটা ৰোল নম্বৰৰ কাৰণে এজন পাৰ্চন বা এজন পাৰ্চনৰ কাৰণে এটা ৰোল নম্বৰ থাকিব। তো ডেট ইজ উই কেন চে 1-to-1 কৰস্পণ্ড। ইয়াক আমি কওঁ 1-to-1 কৰস্পণ্ড। তো ইয়াৰ মিনিংটো এনেকুৱা যে এটাৰ লগতে ই ৰিলেটেড হৈ আছে। তো ইয়াৰ ইনজেকশন ফাংশন বা 1-to-1 ফাংশনো অলমোষ্ট এনেকুৱাই। তো ইয়াৰ ডেফিনেশ্যন হিচাপে চালে কি হ'ব? ফাংশন ইজ 1-1 ইফ no two different pre-image share the same image. So suppose f is a function from a to b, then all the elements of set A are called pre-image, or you can say elements of domain. Elements of domain set, and all the elements of set B, these are called those elements which are related to the pre-images are image. Suppose f of A that is equal to B, then A is the pre-image and B is the image. So by definition, for every image there must be only one pre-image, or else we can say if a function is called 1-1 if no two different pre-image shares the same image. Okay, now suppose f from A to B, and this is A and this is B. Function f a1 a2 and another function suppose there are two functions f from A to B and G is also from A to B. ইয়াতে যদি চাওঁ ডোমেইনৰ প্ৰত্যেকটো এলিমেণ্টেৰ বা এইকেইটা আহিব কি প্ৰি ইমেজ, এইকেইটা আহিল ইমেজ। প্ৰত্যেকটো ইমেজৰ কাৰণে অনলি এটাই কি আছে, ইয়াতে প্ৰি ইমেজ আছে, ৰাইট? চ' দিছ এফ ইজ 1-1। অ'কে, কিন্তু ইয়াতে যদি চাওঁ B1ৰ কাৰণে এটা আছে, B2ৰ কাৰণেও এটা আছে, বাট B3ৰ কাৰণে দুটা আছে, ৰাইট? তো B3ৰ কাৰণে for this B3 there are two pre-images, so that means this is not 1-1. If a function is not 1-1, then we can say that function is many 1. Okay, now যদি মই এফক roster ফৰ্মত লিখোঁ, I can write like this: a1, b2, a2, b1, a3, b3, and g can be written as a1, b1, a2, b3, a3, b3, and a4, b2. From our definition, We can also say that if the second element of the ordered pair is repeating, if the second element of the ordered pair is repeating, then the function is not an 1 1. So for a function to be 1 1, second elements of the ordered pair cannot repeat. Second element of the ordered pairs cannot repeat. Okay. Now see another method, that is we can also detect a 1 1 function by graphical method. Suppose y equal to fx is a function, say fx equal to x square f from r to r. Now see, for any line parallel to x-axis, it cuts the graph at maximum 2 points. Right? Say this point be x1 and this point be x2, and whatever the value, say that is y. So for here you can see f x1 comma y and x2 comma y belongs to f, right? So that means second element of the ordered pair is repeating. So you can say that this function is not a 1 1 function. So we can say any vertical line intersect a 1 1 function at most 1 point. Any vertical line intersect a 1 1 function at most 1 point. Or you can detect if any vertical line intersect the function at maximum 1 point, then the function is called as 1 1 function, right? These are 2 or 3 methods to detect a function whether it is 1 1 or not. But mathematically we can say suppose f is defined from a to b, and for x1 comma x2 belongs to a, if f of x1 that is equal to f of x2, and hence implies x1 equal to x2, then f is 1 1. Okay, তো যদি f of x1 or f of x2 equal হয়, then x1 must be equal to x2. For example, let's take that example from r to r, fx equal to x square. Let x1 and x2 belongs to r. We take two elements from x1 and x2, and if f of x1 that is equal to f of x2, so hence it will come x1 square that is equal to x2 square, or we can write x1 square minus x2 square that is equal to 0, and from this one x1 minus x2 and x1 plus x2 that is equal to 0, or we can say x1 equal to plus minus of x2. Here you can see since the domain is all real number, x1 and x2 could be negative, so x1 is either equal to x2 or equal to negative of x2. Since we are not getting any unique relation between x1 and x2, that these two are equal, we cannot say that this function is 1 1. So f is not 1 1. Okay. Here is one thing. The graph of this function f(x) equal to x square will go like this. So this is the 0 comma 0 for all real number. If I restrict the domain of f from real number to say positive real number or negative real number, say f from r positive to r, then f of x1, that is equal to f of x2, where x1 and x2 belongs to r positive, x1 square, that is equal to x2 square. Here we will only get x1 equal to x2, because since x1 and x2 are positive real numbers, it cannot be negative. Then f is 1 1. Now we can see এটা মেনি ওয়ান ফাংশনক যদি আমি তাৰ ডোমেইনটো ৰেষ্ট্ৰিক্ট কৰোঁ, ডোমেইনটো যদি এডজাষ্ট কৰোঁ, তেতিয়াহ'লে তাক আমি কি কৰিব পাৰিম, 1 1 বনাব পাৰিম, ৰাইট। তো যদি মই ডোমেইন ইফ সেম ফাংশনটোৰে ডোমেইন যদি আৰ পজিটিভ লওঁ, দেন দ্য গ্ৰাফ উড বি লাইক, যদি আৰ পজিটিভ আহে এক্সক্লুডিং 0, এনেকুৱা ধৰণৰ আৰু। হিয়াৰ ইউ কেন চি it cuts the graph at maximum 1 point, right? But when the domain is all real number, then it will cut the graph at maximum 2 points. So when the domain is restricted, then you can say this function is 1 1, or you can say by restricting the domain f can be converted into a 1 1 function. Okay, now here comes the question. If cardinality of A, that is m, and cardinality of B, that is n, then find the total number of one one function from A to B. Now let's see. Suppose this set is A and this set is B. It has m element, say A1, A2, A3 and so on, Am, and it has B1, B2, B3 and up to Bn, say. So there is a map from A to B. So for f to be 1 1, for A1, it has how many choices? It can for A1, it can choose n options, right? N number of options, because A1 can choose B1 also, either B1, or B2 or B3 or Bn, any one of this n element, right? Similarly for A2, how many options left? N minus 1 options left, because 1 is taken by A1. And similarly for A3, it is n minus 2, and so on. For AM, this is n minus m plus 1. So A1, A2, A3 up to AM, A1 has n elements, A2 has n minus 1 element, and so on. A3, AM has n minus m plus 1 element, right? So before AM, total of n minus m plus 1 has already taken. Okay, so now calculate the total number of possible function, total number of possible one function, that is n minus 1, or we can say n minus 2, and so on, n minus m plus 1. We can write it as npm, right? We have already discussed this in permutation and combination. So npm, that means we can say cardinality of b, because the cardinality of b was n, and cardinality of b permutation cardinality of a. And since npm occurs, here comes the condition: n must be greater than or equal to n, or we can say the cardinality of set b must be greater than cardinality of set a, or in other language, uh, the number of elements in the codomain set must be greater than or equal to the number of elements in domain set.